Right now, as you watch this video, our entire galaxy is hurtling through space at over 250,000 miles per hour toward a collision that will reshape everything we know. But here's the twist. This catastrophic event won't happen for another 4 billion years, and when it does, it might be the most beautiful thing the universe has ever orchestrated. Today, we're diving into what really happens when galaxies collide. And trust me, the reality is far stranger and more mesmerizing than you could imagine.
When you hear galactic collision, your mind probably jumps to explosions, chaos, and destruction on an unimaginable scale. But the universe has a different script in mind. These cosmic encounters unfold so slowly and gracefully that calling them collisions almost seems wrong. They're more like elegant dances, choreographed by gravity itself over hundreds of millions of years. Galaxies, those massive cities of stars containing hundreds of billions of suns, aren't stationary decorations in the night sky. They're moving, pulled together by invisible gravitational forces, drawn into encounters that will reshape them entirely. And the wild part? For most of the stars caught in these galactic embraces, life goes on almost undisturbed. In this video, we'll explore the science behind these celestial gatherings, discover what happens to the stars and planets involved, and look ahead to when our own Milky Way meets its neighbor Andromeda in a union that was written into the cosmos long before life appeared on Earth.
Before we dive into collisions, let's understand what we're dealing with. If you could step back far enough from Earth, beyond our solar system, beyond the reaches of our neighboring stars, you'd see that the universe isn't randomly scattered. It's organized into vast, glowing structures called galaxies. These are the fundamental building blocks of the cosmos, immense systems bound together by gravity. Think of a galaxy like a city viewed from above at night. Each light is a star, and together they form patterns and neighborhoods. Our home, the Milky Way, is a barred spiral galaxy containing between 200 and 400 billion stars. And many of those stars host their own planets, and around some of those planets, life might exist. What holds these stellar cities together? Gravity. But here's where it gets interesting. The visible stars and glowing nebulae are only part of the story. There's also dark matter, an invisible substance that makes up most of a galaxy's mass. We can't see it directly, but without dark matter, galaxies would literally spin themselves apart.
Galaxies come in different flavors. Spiral galaxies are the graceful pinwheels we often picture, with long arms curling outward. Our Milky Way belongs to this category. And these spirals are constantly forming new stars in their arms. Elliptical galaxies are smoother, more rounded, and typically contain older stars. Many are thought to be the result of past galactic collisions. They're the universe's elder statesmen. Irregular galaxies defy neat categories, often appearing chaotic. They're usually the result of gravitational encounters that disrupted any organized shape. The universe contains trillions of galaxies, each one a story waiting to unfold. And they're not sitting still.
Galaxies may look frozen in the night sky, but they're constantly in motion. So what drives them together? Gravity is the master choreographer. It's the same force that keeps your feet on the ground, but on cosmic scales, it's powerful enough to pull entire galaxies toward each other across millions of light years. Einstein showed us that gravity isn't really a force pulling objects together. It's massive objects bending the fabric of space and time itself. But gravity alone couldn't explain everything astronomers were seeing. When they calculated how fast galaxies were spinning, something was off. The visible matter, all those stars and gas clouds, wasn't enough to hold them together. According to the math, galaxies should have torn themselves apart ages ago.
Enter dark matter. This mysterious substance doesn't emit, absorb, or reflect light, making it completely invisible. Yet it makes up roughly 85% of all matter in the universe. Think of a galaxy as a glowing lantern surrounded by an enormous invisible balloon. The balloon is dark matter, holding everything in place. Together, gravity and dark matter create the cosmic web, a vast three-dimensional structure where galaxies gather along filaments like cities connected by highways. This web ensures that galaxies aren't isolated. They're participants in an interconnected cosmic dance where encounters are inevitable.
Now for the big question. What actually happens when galaxies collide? Here's the mind-bending truth. Stars almost never hit each other. Even though a galaxy contains hundreds of billions of stars, the distances between them are so vast that direct collisions are incredibly rare. Imagine 2 grains of sand placed several miles apart. That's roughly the spacing of stars in a galaxy. So, what does happen? The gravitational pull of each galaxy tugs on the other, distorting their shapes. This creates tidal interactions that stretch galaxies into long, elegant tails of stars sweeping across hundreds of thousands of light years. Gas clouds, which are much larger than individual stars, do collide directly. When they crash together, they compress, and compressed gas collapses under gravity, triggering massive bursts of star formation. These are called starbursts, and they can create regions where stars are born at rates hundreds of times higher than normal.
The process isn't fast by human standards. A galactic collision doesn't happen overnight. It takes hundreds of millions to billions of years. While galaxies slowly weave themselves together, entire civilizations could rise and fall without ever noticing the change. From our perspective, if Earth were still around during the Milky Way Andromeda collision, the night sky would gradually transform. Andromeda would grow larger and brighter over millions of years until the 2 galaxies interpenetrated like ghosts passing through each other. When galaxies collide, they create some of the most stunning structures in the universe. Tidal tails are elongated streams of stars and gas that extend outward from colliding galaxies, sometimes stretching for hundreds of thousands of light years. They look like ribbons of light drifting into the void, their curves echoing the flow of gravity itself. Bridges form when material is drawn from one galaxy to another, creating luminous threads between them, like cosmic handshakes reaching across the darkness. Streams of stars result when galaxies tear smaller companions apart, wrapping around galaxies like halos or forming graceful loops in space. The sheer beauty of these structures is amplified when observed across different wavelengths. Ultraviolet reveals bursts of new stars. Infrared shows glowing dust heated by stellar nurseries. And radio telescopes map invisible hydrogen gas stretched across vast distances. Each wavelength adds another note to the cosmic symphony. Computer simulations allow us to replay these encounters, watching billions of years unfold in seconds. These models show galaxies swaying and stretching with a grace dictated by gravity's laws, approaching, overlapping, recoiling, and returning like dancers performing an eternal duet.
Some galactic collisions have become cosmic celebrities, the universe's most photogenic couples. The antenna galaxies, located 45 million light-years away, are 2 spirals caught mid-embrace. Their bright centers glow with starburst activity, while 2 enormous tidal tails stretch outward like antennae. Within these tails, clusters of newly formed stars blaze with youthful blue light. The Whirlpool Galaxy, M51, is a stunning face-on spiral being tugged by a smaller companion galaxy. This interaction has enhanced its already elegant spiral arms, triggering bursts of star formation. Images from Hubble reveal dust lanes curving across its arms like delicate brushstrokes.
The Cartwheel Galaxy, roughly 500 million light-years away, has one of the most unusual appearances in the universe. It looks like a glowing wheel with a bright ring surrounding a central hub. This shape formed when a smaller galaxy passed directly through its disk, creating ripples that spread outward like waves on a pond, igniting star formation along the way. Each of these galaxies captures a different stage of cosmic collision, chaos, elegance, and creative transformation, all on display. At the heart of nearly every large galaxy lurks something extraordinary. A supermassive black hole, millions or even billions of times more massive than the Sun. Most of the time, these giants are surprisingly quiet, but when galaxies collide, it's dinner time. The same gravitational forces that stretch galaxies into tidal tails also funnel gas and dust inward toward the galactic centers. This material spirals around the black hole, forming an accretion disk that heats to millions of degrees, releasing tremendous energy before crossing the event horizon. When a supermassive black hole feeds heavily, it creates an active galactic nucleus, AGN, which can outshine all the stars in the galaxy combined. The most extreme examples are quasars, blazing beacons visible across billions of light-years, powered by black holes consuming matter at a furious pace.
During a collision, two galaxies, each carrying a supermassive black hole, will eventually bring their central giants together. Over millions of years, the black holes spiral toward each other, losing energy until they finally merge in a cataclysmic event that releases gravitational waves, ripples in the fabric of space-time itself. These waves, predicted by Einstein and first detected in 2015, allow us to hear the universe in a completely new way. Future space-based detectors like LISA will track the slow, deep rumble of supermassive black holes merging across the cosmos.
Let's zoom in from the galactic scale to something more personal. What would a collision feel like to an individual star? The answer might surprise you. Not much. For most stars, a galactic collision is less like a car crash and more like a slow drift through a changing neighborhood. Remember, stars are separated by such vast distances that even when galaxies interpenetrate, direct collisions are vanishingly rare. What does change is a star's motion. As the gravitational field shifts, stars are pulled into new orbits. Some stretched outward into long arcs, others nudged closer to the galactic center. But these changes happen over millions of years, so gradually that a single civilization would never notice.
For stars with planets, like our Sun, the story remains calm. The star's gravitational grip on its planets is much stronger than any distant tidal forces. This means solar systems are usually preserved intact during collisions. Earth would continue orbiting the Sun, seasons would pass, and life, if it existed, could carry on. The view from the surface, though, would eventually become extraordinary. Over millions of years, the familiar constellations would slowly distort and change as the galaxy reshaped itself. New star patterns would emerge, and perhaps a second galactic core would grow brighter in the sky. From the star's perspective, there's a profound serenity in all this. While galaxies twist and merge around them, stars continue shining steadily, following the gravitational script written for them. They're patient witnesses to cosmic transformation.
While direct star collisions are rare, galactic mergers are actually stellar nurseries on overdrive. When gas clouds within colliding galaxies crash together, shock waves ripple through them,
compressing the gas. Compressed gas collapses under gravity, and presto, new stars are born. During a star burst, a galaxy can produce stars at rates tens or hundreds of times higher than normal. Massive, hot, blue stars ignite in brilliant clusters, radiating tremendous energy. Though they live only a few million years before exploding as supernovae, they reshape their environment, seeding it with heavy elements. Nebulae play a starring role in this process. These colorful clouds, like the famous Orion Nebula, glow in vivid hues during collisions. Each color corresponds to different elements: red from hydrogen, green from oxygen, blue from helium. They're like cosmic gardens in full bloom.
The poetic image of galaxies as gardeners is fitting. They scatter seeds of starlight, cultivate fresh clusters, and replenish the universe with matter. Old stars die, their remains enriching space with heavier elements. Collisions then stir that material into new shapes, ensuring the cycle continues. Without galactic collisions stirring the pot and triggering waves of star formation, the universe might never have become chemically diverse enough to produce planets like Earth, or life as we know it.
Eventually, every collision reaches its finale. After hundreds of millions of years of chaos, galaxies enter a quieter phase. Tidal tails gradually dissipate, bridges collapse. The distinct identities of the original spirals blur into one. Gravity pulls everything toward balance. The result is typically an elliptical galaxy, a smooth, rounded form filled with older stars. Ellipticals are less ornate than spirals, but carry their own quiet dignity. They're like the elder statesmen of the galactic world, no longer producing stars with youthful vigor, but shining steadily with accumulated ancient light.
This transformation represents a kind of cosmic maturity. The galaxy has survived upheaval, undergone renewal, and emerged calmer. The silence after collision isn't an absence, it's a different kind of beauty, a sunset stretching across billions of years. Many of the giant elliptical galaxies we observe today are the products of countless past mergers. Their immense size and smooth appearance tell stories of violent pasts that have long since settled into peaceful old age.
Now let's bring this home, literally. If you look toward the constellation Andromeda, you can see a faint smudge of light with the naked eye. That's the Andromeda Galaxy, our nearest large neighbor, and it's heading straight for us. Before you panic, let's clarify. This won't happen for another 4 billion years. By that time, Earth's continents will be unrecognizable, the sun will be brighter and hotter, and our species will either be gone or transformed beyond imagination. Astronomers have measured Andromeda's motion. It's approaching at about 110 kilometers per second. That sounds fast, but considering the 2.5 million light-year distance, this is an incredibly slow, steady approach. When the collision begins, Andromeda will grow larger in the night sky over millions of years, eventually transforming from a faint smudge into a luminous disk dominating the heavens. The two galaxies will interpenetrate, their stars passing through each other like ghosts. The merger will play out over billions of years, multiple close passes throwing out tidal tails before the galaxies finally settle into a single structure, likely an elliptical galaxy, sometimes playfully called Milkdromeda. Our solar system will probably survive, though its position might change. We could be flung farther from the galactic center or drawn closer. The night sky would be transformed beyond recognition.
Thanks to powerful computers, astronomers have already watched our galactic future unfold in simulation. By feeding in what we know about the Milky Way and Andromeda, their masses, shapes, and velocities, computers can run the equations of gravity and show us what happens. The results are stunning. The galaxies weave through each other in a drawn-out embrace. On first pass, gravitational tides pull out long streams of stars. The galaxies recoil, then swing together again. This cosmic dance repeats, each encounter stripping away more structure until they coalesce into one. The entire process takes several billion years, but in simulation, it unfolds in minutes. What emerges is a large elliptical galaxy containing over 1 trillion stars, roughly double the combined population of its parents. The delicate spiral arms are torn and twisted until they resemble ribbons, eventually smoothing out into a rounded, featureless glow. These simulations also reveal the crucial role of dark matter. Though invisible, dark matter halos extend far beyond visible stars. When galaxies merge, these halos collide first, their gravity dragging the visible galaxies together. Smaller companion galaxies like the Magellanic Clouds and Triangulum may also be drawn into the merger, making Milkdromeda a composite of many smaller systems.
Our future merger isn't unique. Collisions have been shaping the universe since the beginning. In the early universe, roughly 13 billion years ago, galaxies were smaller, closer together, and collisions were far more common. These encounters weren't gentle. They were gas-rich affairs that triggered massive starbursts. This process, called galactic assembly, built the large galaxies we see today. Even majestic spirals like the Milky Way have rough histories hidden within their stars. Our galactic halo contains remnants of dwarf galaxies absorbed billions of years ago.
By studying stars' chemical fingerprints, astronomers have pieced together the Milky Way's family tree. It turns out we've already consumed dozens of smaller companions throughout our history. Collisions also played a central role in distributing heavy elements. The first stars formed almost entirely from hydrogen and helium. It was through supernovae, especially those triggered by collision-induced starbursts, that heavier elements like carbon, oxygen, and iron were scattered across space. Without galactic collisions, the universe might never have become chemically diverse enough for planets and life to form. In this sense, cosmic violence paved the way for cosmic fertility.
Not all galactic encounters are between equals. Sometimes it's less collision and more cosmic snacking. Galactic cannibalism occurs when a large galaxy slowly consumes a smaller one, pulling it apart star by star until little remains but faint streams of debris. The Milky Way is currently devouring the Sagittarius dwarf spheroidal galaxy. Discovered in the 1990s, this small galaxy is being stretched into a long ribbon of stars that wraps around our galaxy like a tattered scarf. Each pass through the Milky Way's disk tears away more material. This isn't rare. Observations of giant elliptical galaxies reveal halos littered with faint tidal streams, signatures of their gluttonous pasts. These giants are the heavyweight champions of galactic dining, their immense size the result of billions of years spent absorbing neighbors.
Even Andromeda shows evidence of past meals in its complex halo of stellar streams. Why does this happen? Large galaxies sit within massive dark matter halos that extend far beyond visible stars, creating immense gravitational wells. Smaller galaxies that wander too close become trapped, their orbits decaying over billions of years until they're completely absorbed. Despite the ominous name, galactic cannibalism isn't destructive. It's one of the main ways galaxies grow. The stars from consumed dwarf galaxies don't vanish. They join the larger system, continuing to shine in new arrangements.
One collision in particular revolutionized our understanding of the universe: the Bullet Cluster. Located 3.8 billion light-years away, is the aftermath of two galaxy clusters colliding at high speed. When astronomers studied it using multiple techniques, they found something extraordinary. X-ray telescopes showed hot gas glowing between the clusters, piled up where the gas clouds slammed together and slowed down during collision. But when they mapped the mass distribution using gravitational lensing, studying how background galaxies were distorted by gravity, they found most of the mass had passed straight through. This invisible mass was sitting around the galaxies themselves, not with the hot gas. The conclusion was inescapable. Dark matter must exist, acting as a ghostly companion that doesn't collide, but simply glides through itself.
The Bullet Cluster became smoking gun evidence for dark matter, showing a literal separation between visible matter and the bulk of mass. It proved that roughly 85% of the universe's matter is invisible, shaping everything through gravity alone. During collisions, dark matter's behavior is crucial. While ordinary matter crashes and slows down, dark matter halos interpenetrate without friction. This is why galaxies can pass through each other during mergers, while their invisible frameworks remain intact.
Zoom out far enough, and you'll see that galaxies aren't scattered randomly. They're organized into the cosmic web. This vast, three-dimensional structure shows galaxies gathered along filaments of dark matter, forming clusters and superclusters. Between these filaments lie immense voids, regions nearly empty of galaxies. From this perspective, collisions aren't isolated accidents, but natural consequences of the web's structure. Galaxies flow along filaments toward dense intersections, where encounters become inevitable.
The Milky Way belongs to the local group, which is part of the Virgo supercluster, which itself is just one section of the even larger Laniakea supercluster, a vast continental-like feature spanning over 500 million light-years. Understanding collisions within this context reveals them as part of a grand pattern. The universe is constantly reshaping itself as matter flows through the cosmic web, with mergers serving as the threads that weave galaxies more tightly into the fabric of existence.
What happens if we fast forward the clock billions of years into the future? Collisions will continue, but their character will change. Within gravitationally bound groups like ours, galaxies will keep merging until only a few massive ellipticals remain. The local group will eventually become a single giant galaxy. But here's the twist. Cosmic expansion is carrying distant galaxies away from us faster and faster, driven by dark energy. Eventually, only galaxies gravitationally bound to us will remain accessible. Everything else will slip beyond the cosmic horizon.
Imagine a civilization living trillions of years from now. When they look up, they'd see only their own colossal merged galaxy dominating an otherwise empty cosmos. The countless galaxies we observe today will have disappeared from view, carried away by expansion. Over even longer timescales, star formation will slow and eventually stop as gas is consumed. The great elliptical galaxies will gradually age into quiet collections of red dwarf stars, then eventually into collections of stellar remnants, white dwarfs, neutron stars, and black holes drifting silently through darkness. Galactic collisions will still occur in this distant future, but they'll be muted affairs, mixing populations of dead stars rather than sparking new life.
So why should we care about events that unfold over billions of years? Galactic collisions matter because they're the architects of cosmic structure. Without them, galaxies might have remained small and irregular. Instead, mergers built the majestic spirals and massive ellipticals we see today. They triggered the starbursts that enriched the universe with heavy elements, the carbon, oxygen, and iron that make planets and life possible. Every atom in your body was forged in stars, and many of those stars were born because galaxies collided. These encounters also reveal hidden truths about the universe, the existence of dark matter, the behavior of gravity across vast scales, and the interconnectedness of all cosmic structures.
Beyond science, collisions remind us that change, even dramatic upheaval, isn't destruction, but transformation. Galaxies endure through these encounters, becoming something new, but never ceasing to exist. Stars carry on, solar systems survive, and beauty emerges from apparent chaos. There's profound comfort in the patience these events display. Collisions unfold over hundreds of millions of years, showing that the universe moves with deliberate grace, not violent haste.
Galactic collisions are not the catastrophes we might imagine. They're slow, graceful transformations, cosmic dances choreographed by gravity across billions of years. Stars rarely collide. Planets continue their orbits. Gas clouds compress and birth new generations of stars. Black holes feed and grow. And eventually, two galaxies become one, settling into a new form that carries the memory of both. Our own Milky Way is destined for such a future. In roughly 4 billion years, Andromeda will arrive, and the dance will begin. By then, everything we know may have changed beyond recognition, but the stars will endure, shining steadily as they've always done.
There's no need to fear this distant future. Instead, we can marvel at it, at the patience of the cosmos, at the beauty emerging from transformation, at the resilience of stars and galaxies across unimaginable spans of time. When galaxies collide, they don't end, they evolve. They show us that even in the universe's most dramatic moments, there's grace, order, and an enduring beauty that transcends destruction. So the next time you look up at the night sky and spot that faint smudge of Andromeda, remember, you're looking at destiny in progress. A slow-motion collision that's already been set in motion. A future written in starlight, unfolding with the patient elegance that only the universe can muster. And in that thought, there's something deeply calming, a reminder that we're all part of something vast, ancient, and profoundly beautiful. A cosmic dance that's been playing out long before we arrived and will continue long after we're gone. The universe moves with patience, and so perhaps should we.